Imagine putting a firecracker inside a metal bucket and lighting it up. The explosion creates a shock wave that blasts the lid right off the bucket. Now, what if we flip things around? Seal the top and put the lid at the bottom of the bucket instead. The shock wave would push the lid downward. To keep the lid from flying off completely, engineers added a connecting rod that moves up and down, attached to a crankshaft below. This moving lid becomes the engine's piston. To make it easier to add more firecrackers, they cut a hole in the top. This way, they could keep pushing the piston down. But here's the problem. Once the piston gets blasted down, it can't get back up on its own. So engineers added a flywheel to the crankshaft. The flywheel's momentum keeps the crankshaft spinning and brings the piston back up. Using actual firecrackers as fuel was pretty impractical, so they installed a fuel injector at the top instead. This sprays a fine mist of fuel into the chamber. Then they added a spark plug to ignite the fuel mixture. But here's the thing. Combustion needs oxygen to work. That's when engineers added intake and exhaust valves at the top. When the intake valve opens, the fuel injector sprays fuel, which mixes with air as it's sucked into the cylinder. The spark plug fires, igniting the mixture. The exhaust gases from combustion get pushed out through the exhaust valve. By repeating this cycle over and over, the piston keeps moving up and down continuously, and that's exactly how an internal